MS Ramaiah University of Applied Sciences.
Hi students, let us discuss the experiment to construct SR, JK, T and D flip-flops. Aim of the experiment is to construct and verify the functions of SR, JK, T and D flip-flops using NAND and NOR gates. Flip-flops and latches are a fundamental building block of digital electronic systems used in computers, communications and many other types of systems. Flip-flops and latches are used as data storage elements. The logic diagrams and truth tables of SR and JK flip-flops are as shown in figure. The logic diagrams and truth tables of D and T flip-flops are as shown here. The apparatus required for this experiment are trainer kit, connecting probes IC 7400. Procedure for verification of flip-flop functionalities. Draw a logic diagram that represents the implementation of the design. Insert the appropriate IC into the IC base. Make connections as shown in the circuit diagram. Verify the truth table and observe the outputs. Conclusion. The functionalities of SR, JK, T and D flip-flops are verified by obtaining their truth tables experimentally.
Hi students, name of the experiment is construct SR, JK, T and D flip-flops. Aim of the experiment is to construct and verify the functions of SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. The operators required for this experiment is digital IC trainer kit. So this is the digital IC trainer kit which we are using to perform the experiment. So it consists of output pins here at the top. So here you can see there are 10 different knobs which are in red color, indicates the outputs. So the output can be seen using the LED bulbs which are there just above the notch. Here at the bottom again you can see there are 10 black color knobs which represents the inputs. Here we are going to connect the inputs. The input can be operated by operating the toggle switches which are there at the bottom of the input knobs. So when the toggle switch is in the top position, it says the input is logic high. When is at the bottom position, it says the input is logic low. At the same time, the digital IC trainer kit has 4 different IC bases. So here we can place 4 different ICs. So this is first IC base, second one, this is third IC base and this is fourth IC base. In each IC base we can place one IC. And here you can see these are the slots. There are 16 slots in this IC base. So we can place a IC which has a 16 slots. But in our experiment we are using a IC which has a 14 pins. So the remaining 2 pins will be left free. And these are the pins you can see. So these are used to connect IC to each pin. So it has a red pin at the top. This represents VCC and black pin at the bottom, this represents the ground. So these 2 pins are used to give a power supply to the IC, that we are giving 5 volt to DC supply by connecting this. Now at the bottom you can also see there are green color knobs which represents the clock signals of different frequencies, 1 Hz, 10 Hz, 100 Hz, 1 kHz and 10 kilohertz. And also at the right side of this you can see the mono pulsar. This is high, this is low, this is for the positive edge trigger and this is for the negative edge trigger. By operating the button here we can trigger the clock pulse. And here you can see 2 yellow knobs. These are used to check the continuity of the patch cords which we are using in this experiment. So by connecting the patch cords here you can see a LED bulb on. If the LED bulb is on and there is a beep sound, that means the patch cord is working properly. If the LED bulb is not on and if the beep sound is not coming after you connect the patch cord here, that means the patch cord is not working properly. ICs, So these are the two ICs which we are using to conduct this experiment. The first IC is 7400, this is NAND gate and it is a 14 pin IC, and the second one is 7404, this is a NOT gate and it also has 14 pins. These two we are using in this experiment. And patch cords. So these are the patch cords which we are using to connect the circuit as per the circuit diagram. Now let us start the connections as per the logic diagram. So first let us start the construction and verification of SR flip-flop using NAND gates. Before connecting the logic diagram, let us check the conductivity of the patch cords. This is the patch cord, so we need to check the conductivity of this patch cord. So for that we need to turn on the power supply to the digital IC trainer kit. So you can turn it on by turn on the switch at the back side. So the LED bulb is on, this indicates the digital IC trainer kit is on. So now I am placing the patch cord into the continuity tester. So as I told, you can see there is a LED bulb on and there is a beep sound. So that means this patch cord is working properly. You can use this patch cord for the experiment. In a similar way you have to do for all the patch cords. After checking the conductivity of the patch cords, so now let us place the IC into the IC base. So now this is a 7400 IC. This represents NAND gate and we have to place this IC into the IC base here. And as I told, this is a 14 pin IC. While you are placing this IC into the IC base, we have to make sure that there is a notch at the top of the IC, so that should be always in the upward direction. So there is a notch here, so I am going to place it into the IC base. Before placing into the IC base, there is a lever, make it open, then place the IC from the top, place it firmly and close the lever and make sure the IC is not coming out. So the IC has been placed into the IC base successfully. So now let us connect the circuit as per the logic diagram. So before connecting the circuit, make sure you are giving VCC and ground. So this is to give the power supply to the IC. So if you connect VCC and ground, so it will give 5 volt DC power supply to the IC. So therefore I am connecting VCC to the pin number 14. So the pin number 16 we have to consider as pin number 14, since we are not using the last two slots here, because the given IC consists of only 14 pins. The last two slots are left free. So therefore immediately after 7 we have to consider this pin as 8, this pin as 9, 10, 11, 12, 13, 14. So therefore 14 pin is connected to VCC and pin number 7 is connected to ground. So this is pin number 7 which should be connected to ground. So now after this let us start connecting the original circuit. So pin number 1 is the input. So as I told, these are the input pins. You can connect anywhere here. So I am connecting to the pin number 1 here. So this represents S input. Next, pin number 2 and pin number 4 are shorted, and from the same pins, whether from the pin number 2 or from pin number 4, you can take one more and you can connect it to the clock. So clock signals are here. So I am choosing 1 Hz frequency. I am connecting it here. So then pin number 5 is one more input. This represents R input. So therefore I am connecting here. So therefore 2 inputs are connected now. One is S, one is R. Now pin number 3 is connected to pin number 9. So pin number 9 is nothing but this. So now pin number 6 is connected to pin number 13. This is pin number 13. Next, pin number 10 is connected to pin number 11. So 10 and 11 are shorted. Pin number 8 is connected to pin number 12. So now this completes the inputs. Now I am giving the outputs. The outputs are taken from pin number 8 as per the logic diagram. So pin number 8 is one output. So output can be connected anywhere here. So I am connecting to the first knob. So this represents Q output, and the other output is taken from pin number 11. So here, so this is the complement of the previous output, that is Q bar now. So Q and Q bar are the outputs, S and R are the inputs. So this completes the circuit connections. So now we will verify the outputs. So in order to do that, first we need to switch on the power supply, so that can be turned on by turning on the switch at the back side. So here you can see red LED bulb is on, that means the circuit is on. So now we have to verify the outputs by changing the input knobs. So as per the truth table, so whenever both inputs are low, that means 0 0, SR inputs are 0 0, so the output is in the no change state, that means it will be there in the previous state, that is 0 1. So when I change the inputs 0 1, 0 to 1, this is the first input is 0, the second input I will make it high, so that time you can say the output Q is 0, the output Q bar is 1, so that means it is a reset state, I can say. So now next I will change the input from 0 1 to 1 0, so I will make it 0, I will make the first input S input as a high, so that time you can see the output Q is high, Q bar is 0. You can check the outputs by looking into the LEDs. Now the last combination of the input is, I will make both the inputs S and R as a high, so that time you can see a forbidden state here, so not valid state. So that means we have verified the truth table, so this completes the experiment. We have verified the SR flip-flop. Now let us verify the JK flip-flop as per the logic diagram. So to implement this experiment, we are using a 3-input NAND gate, that is 7410, and 2-input NAND gate, that is 7400. So now let us place the ICs into 2 IC bases. First I am placing 3-input NAND gate into the first IC base. After placing it, close the lever. Then this is another one, 2-input NAND gate, that is 7400. Place it into the second IC base and close the lever. So now let us connect the circuit diagram as per the logic diagram. So now before connecting inputs and outputs, let us connect VCC and ground for each IC base. There are 2 IC bases where I have placed ICs. So VCC is pin number 14, pin number 7 is ground. Similarly for second IC base, pin number 14 is VCC and pin number 7 is ground. Now pin number 1 of the first IC base is connected as input. I am connecting to the input knob. This represents J input, and pin number 13 of first IC base is connected to pin number 3. Now from either of these 2 pins we need to take one terminal and I need to connect it to clock. So therefore I am connecting from pin number 3, so I will give it to clock pulse. Now pin number 4 is another input that represents K input. I am going to connect it to the input knob. Then pin number 12 is connected to pin number 1 of the 2-input NAND gate, that is the second IC base. Here I am connecting. Then pin number 6 of first IC base is connected to pin number 5 of second IC base. And pin number 2 of first IC base is connected to pin number 6 of second IC base. Pin number 5 of first IC base is connected to pin number 3 of second IC base. Then pin number 2 of second IC base is connected as pin number 6 of the same IC base, that is here. Then pin number 4 of second IC base is connected to pin number 3 of the second IC base itself. So now we need to connect the outputs. So outputs are taken from pin number 3 and pin number 6 of the second IC base. So first I am taking from pin number 3. So this represents Q output. So I am going to connect it somewhere in the output knob, and one more output is taken from pin number 6. It is connected in the output knobs. This represents Q bar. So Q and Q bar are here, and inputs JK are connected here, and clock pulse is connected here. So this completes the circuit connections. Now we will verify the outputs according to the truth table. So before that, let us turn on the power supply to the IC kit. So now it is on. So now we will try to change the inputs, so as per the truth table. So now the inputs, when the inputs are 0 0, the outputs will be in the no change state. That means it will store the previous data. So I will change the inputs from 0 0 to 0 1. So that time Q will be 0, Q bar will be high. That is called as the reset state. Then I will try to change the input combination from 0 1 to 1 0. So that means first one I will make it high, second one will be 0. That time Q will be high, Q bar will be 0. So this represents this set state, and the last combination of the input is 1 1. So that times you can see the toggle in the output. So that means we have verified the truth table, so it is correct. This completes the experiment. So we have verified the JK flip-flop. Now we will construct and verify the T flip-flop as per the logic diagram. So to construct and verify the T flip-flop, we require again two NAND gates. One is 3 input NAND gate, that is 7410, and another is 2 input NAND gate, that is 7400. Now let us place these two ICs into the IC base. So first I am taking 3 input NAND gate 7410 and I am placing into the first IC base, and close the lever, make sure it will not come out. And similarly the second IC I am placing into the second IC base and close the lever. Now let us connect the circuit as per the logic diagram. So before I connect the circuit, I will just connect VCC and ground for each IC base. Pin number 14 represents VCC and pin number 7 represents ground. Similarly for IC base 2, pin number 14 represents VCC, pin number 7 represents ground. And here as per the logic diagram, pin number 1 represents the input, that is T input. It has only one input, that is T input. I have connected here. Then pin number 3 and pin number 13 are shorted. So from the same terminals we have to give clock. So I will take connection from pin number 3 and I will connect it to the clock at the bottom. Now pin number 2 is connected to pin number 6 of the 2 input NAND gate, that is second IC base. Next pin number 6 is connected to pin number 5 of the 2 input NAND gate, that is there in the second IC base. Pin number 12 of the 3 input NAND gate is connected to pin number 1 of the 2 input NAND gate. Pin number 2 of the 2 input NAND gate is connected to pin number 6 of the 2 input NAND gate. Pin number 4 of 2 input NAND gate is connected to pin number 3 of 2 input NAND gate. Next we have to connect pin number 4 of 3 input NAND gate to pin number 1 of the 3 input NAND gate. Both of them are shorted since there is single input. Then pin number 5 of 3 input NAND gate is connected to pin number 3 of 2 input NAND gates. So now we have connected all the inputs. Now we will connect the outputs. So outputs are taken from pin number 3. So one output, this represents Q. I will connect here to the output knob, and another output, that is pin number 6 of the 2 input NAND gate, and I am connecting to the output knob, that is Q bar. So there is one input T input and there are two outputs Q and Q bar as per the logic diagram. This completes the circuit connection. Now we will verify the outputs according to the truth table. So before that, we will turn on the power supply to the digital IC trainer kit. So by turning it on the switch at the back side, so now it is powered up. Now we will verify it according to the truth table. So there is a single input, only T input. When the T is 0, the outputs are in the previous state, that was 1 and 0. So when I make T high, so the output will toggle. As you can see, the output is toggling. So this verifies the T flip-flop. So therefore we have completed the experiment. So verification of the T flip-flop is over. Now let us construct and verify the D flip-flop as per the logic diagram. So to implement the given logic diagram, we require two ICs. One is 7404 NOT gate and another is 7400 NAND gate. Now let us place these two ICs into the IC base. So first I am placing 7400 NAND gate into the first IC base. After placing it, close the lever. Then another IC 7404 NOT gate. Place it and close the lever. Now let us start connecting it as per the logic diagram. So before that, I will connect VCC and ground for both IC bases. Pin number 14 represents VCC and pin number 7 represents ground. Similarly, pin number 14 of the second IC represents VCC. Pin number 7 represents ground. Then pin number 1 of the NAND gate is connected to the input. This represents the D input, and similarly the same way we have to connect pin number 1 to the pin 1 of the NOT gate, that is here. Now pin number 2 of the NOT gate, that is output of the NOT gate, is connected to pin number 4 of NAND gate, and pin number 5 of NAND gate is connected to clock. Pin number 2 of NAND gate is shorted with pin number 5. Pin number 3 of NAND gate is connected to pin number 9 here. Pin number 6 of NAND gate is connected to pin number 13, that is here. Pin number 10 and 11 are shorted. Pin number 12 and 8 are shorted. So this is 8 is shorted with pin number 12. Now inputs we have connected. Now we will take the outputs. Pin number 8 represents Q output. I am connecting it to the output here, and pin number 11 represents one more output, that is Q bar. I am going to connect it at the output knobs. So these are the two outputs, Q and Q bar, and this is the input, that is D. So this completes the circuit connections. Now let us verify the D flip-flop according to the truth table. So now before that, I will turn on the power supply to the digital IC trainer kit. So power is turned on. Then we will check or we will verify the truth table. So when the input D is low, the output Q and Q bar will be there in the previous state, that is 0 and 1. And when I change the input to 0 to 1, then I can see here the output Q is high, the Q bar will be low. So that means this is correct according to the truth table. So this completes the experiment. So we have verified JK flip-flop, SR flip-flop, D flip-flop and T flip-flops using NAND gates. So this completes the entire experiment.
At MSR UAS, we spark your imagination. unlike any other.